What you're about to witness in this video is the self-destruction of the world. While we was being distracted, all of this has been going on and pre-planned. Now it has come to the head to now, what would we do afterward? This has also been already pre-planned in the beginning. This is the beginning of the end. The earthquakes, the flooding, the hurricanes, the high heat, all this is man-made and created. If you don't understand this, this video might enlighten you. We are now living in the end times.
Longest running cloud seeding operations in the country. We've got some ground-based cloud seeding equipment right here, and we're gonna get to hear all about how it works and see it in action. Let's check it out. Cloud seeding is the most common type of weather modification, and it has many different techniques and applications. Today, it's mostly used to increase rain and snowfall, reduce the size of hail, and reduce fog at airports.
Traditionally, cloud seeding has been done from the air. So airplanes have had racks on them where these same flares are positioned on the airplane, and the airplane flies into the storm. So in order to reduce the cost to the client and reduce our carbon footprint, we've been able to station these on the ground. Now we can do this in places where weather permits.
Behind a barbed wire fence designed to keep away curious cattle, the cloud seeding gear awaits the right kind of weather.
So these are referred to as AHOGs. That stands for Automated High Output Ground Seeding Systems. We've got three primary components of our equipment here. The first is the control module that you see behind me. Then we have our actual cloud seeding flares. The cameras for security. It also helps us observe weather conditions in real time and make sure that all of the equipment is operating correctly during a storm. Inside these canisters are the flares with the seeding agents. The canisters are used as spark arresters, so they prevent sparks from reaching the ground. So if we pull off the spark arrestor, you can see the flare inside. The ignition of the flares are controlled from the control module that's behind us. So the white triangle there is a cell service modem, and then the solar panel keeps us powered. Inside we have a battery and then a control board. So the control board interacts with the software. We're linked or synced with the software in Utah currently, and that allows us to fire or ignite any of the flares from that remote location.
Because
Worldwide focus on the power of water. Just this week, a stretch of the Colorado River was named the most endangered river in the United States as overuse and climate change threaten this national treasure.
But we are now learning about an innovative practice being used to help combat these effects and give Mother Nature a much needed boost. ABC Chief Meteorologist Ginger Zee has more on that. Take a look.
The Colorado River, called the hardest working river in the United States, is in danger.
This is due to two causes: reductions in precipitation and increased air temperatures.
The river provides hydropower to 7 states, irrigation to more than 5 million acres of farmland, drinking water to 40 million Americans, and of course, the breathtaking Whitewater Rapids running through the Grand Canyon. All of it threatened by more than 2 decades in a megadrought. We can't just flip a switch like Colonel Joe Moore in Mad Max Fury Road. But we do have a superpower. Straight out of science fiction's X-Men: The Last Stand. It's called weather modification, or cloud seeding.
We can't create the cloud. There has to be an existing storm system.
We just give it a bump.
Yeah.
Garrett Kamens heads up one of the largest cloud seeding companies in the U.S.
Has the desperation in the mega drought made the interest in cloud seeding skyrocket?
Oh, definitely.
There are currently 42 cloud seeding projects across the American West, like this one in Utah, where they take planes like this with flares attached. They fly right into the storm and send microscopic particles into the cloud.
Particles that act like magnets for water droplets, bonding together until they are heavy enough to fall to the ground as rain or snow. At the University of Colorado, researchers are working on artificial intelligence to deploy cloud seeding drones.
And it's not just cloud seeding from the sky. There are hundreds of those things. That shack you see in the foreground is a ground-based cloud seeder. The little flame coming out is sending tiny silver iodide particles up into the sky. When a storm comes through, they go up to 2,000 feet above our head, into the storm, up those mountains, and make more snow than it naturally would.
While cloud seeding has been helping get every last drop out of some of the driest years on record, this past winter, Mother Nature came through. The Southern Rockies, which feed the Colorado River, got more than 4 times their average snow. But experts say it's still not enough.
As much as cloud seeding is a boost or a help, it's not a solution. The main solution is
Conservation.
Here in Modesto, California, pilots are prepping this plane to fly into the center of a storm. Flares on the wings and fuselage will inject a substance called silver iodide into the storm clouds, causing water within the clouds to freeze and increasing the amount of precipitation that falls.
We can't make a storm happen, and we can't create conditions in the storm that are ideal. Those happen naturally, and what we're doing is just taking advantage of existing conditions, naturally occurring conditions, and trying to make the storm, again, more efficient from a water supply perspective.
It's called cloud seeding, and as futuristic as it sounds, it's been around since the 1940s. Today, states, utility companies, and ski resorts alike pay companies like Weather Modification International significant money to seed storm clouds and increase snowfall in the drought-ridden American West and worldwide.
Our current project is about $4 million a year. We're very well supported. We have a lot of local stakeholders that are investing in it.
Until recently, the evidence for cloud seeding's efficacy was murky, but research has finally shown unequivocally that it works, and there's been no evidence to show that the seeding agent, silver iodide, is harmful at the current level that it's used. Blestrud says that Idaho Power sees an 11 or 12% increase in snowpack in some areas that it seeds, while Karkit says Turloc's program results in about 60 to 90,000 extra acre-feet of water every year. While it's no cure for the West's historic drought, dozens of cloud seeding programs across the country are ramping up right now as winter gets underway.
These are the flares that we will use when we're above cloud, and we need to get the flare down into the cloud. When we're in cloud, we will be using the burn-in-place flare, which can be ignited from the cockpit one at a time. They burn for 4 to 4.5 minutes, and they just trail smoke out with the silver iodide.
The world's first cloud seeding experiment, back in 1946, was a bit more simplistic than Zimmer's current setup.
There was a group of scientists back in New York that worked for the General Electric company. They released some dry ice into the top of a supercooled stratus cloud and caused ice to form. And that ice formed and used up the available liquid water of the cloud drops, and the cloud seeding was thus born.
And now we're going to do a deep dive with Davo. Dubai is making it rain in a sweltering desert by zapping clouds with electricity using drones.
Fascinating, isn't it?
So much to ask, but let's take it, and then we'll do a few questions.
Before we talk about what's happening in Dubai, let's talk about cloud seeding in general, because a lot of people, I don't think, understand what cloud seeding is. And this has been going on for decades, by the way. This is not something that's brand new. But traditionally, what cloud seeding is, it involves using aircraft or drones or even some cannons to push silver iodide up high into the clouds. Why silver iodide? Because what that has the same crystallized structure as ice. So once it gets up into the clouds, it starts to accumulate ice on it and these large raindrops, which helps, especially in a cloud mass that's not really going to rain. It helps to bring rain and especially snow down.
So it works.
It does work. Marginally. But the problem with silver iodide through the years has been this, is that they feel it could be harmful to aquatic life. Okay. So over in Dubai, which is what you're seeing here, they took it a different step, and what they basically did, they had a fleet of drones that flew up into cloud cover, and they used electrical charges to force water droplets to combine into larger ones.
So not silver, not cloud seeding as we know.
No, they're not using the traditional silver iodide, which takes out the environmental aspect of that, okay? So they're using just electricity to create larger raindrops. Why larger raindrops? Because in Dubai, they only average about 4 inches of rain per year, as most of the rain that falls out of the clouds evaporates.
The number of fires burning across Brazil's Amazon rainforest has prompted renewed global outcry over climate change. And big spending. $5 million from Leonardo DiCaprio, £10 million from the UK. Meanwhile, Bill Gates is backing the first high-altitude experiment of one radical climate change solution, creating a massive chemical cloud that could cool the Earth. It's called solar geoengineering, and it's highly controversial.
How long will it be that countries keep experiencing these climate impacts before someone gets desperate and says, hey, we need to cool the planet with solar geoengineering?
It would look something like this. Thousands of planes would fly very high and use nozzles to inject millions of tons of light-reflecting particles into the stratosphere. It would create a thin chemical cloud of those particles around the whole planet, blocking some sunlight from reaching the surface. It would mimic a giant volcanic eruption, which we know cools the Earth. Back in 1991, Mount Pinatubo erupted in the Philippines. It was the largest eruption to affect a densely populated area, creating avalanches and giant mud flows that left more than 700 dead and 30,000 homeless. It also spewed a cloud of 20 million tons of sulfur dioxide particles into the stratosphere. That chemical cloud was hundreds of miles across and reflected about 2% of sunlight back to space. And in 1992, the Earth was cooler than in 1991.
That is part of the mechanism, but you do this in a controlled way.
Modeling studies have found that it could reduce the intensity of heat waves, for instance. Apparently it could reduce the rate of sea level rise. It could reduce the intensity of tropical storms.
But it also comes with significant risks and uncertainties.
Things like mass famine, mass flooding, drought, of kinds that will affect very large populations.
It could weaken